Acid rain sounds like something straight out of a sci-fi film, like strange raindrops that fall on a city and corrode everything. The truth is not far off, but the good news is that we know a lot about what causes acid rain and how to address its impact on the environment, our bodies, and the built world. Interestingly, normal rain is actually slightly acidic as well. If you think back to the pH scale, you'll remember that it goes from 0 to 14, acidic to basic, and that 7, right in the middle, is neutral. Normal rain is around 5 or 5.5, so it's slightly acidic. But acid rain is even more acidic and typically around a pH of 4. Now, this might not sound like a big difference, but remember that this is a logarithmic scale. So each increment, like from 4 to 5, is actually a tenfold difference. So if we're comparing normal rain at about 5.5 and acid rain at 4, that's a pretty big deal. So now the questions are, how does acid rain form? Why does it matter? And what effects can acid rain have on our communities? So the short answer to how it forms is pollution. So let me try to bring that to life for you with my imaginary hand-drawn city. Now remember that most of the fuels we burn to make energy are from fossil fuels, so that animal and plant matter that has been in the ground for millions of years. And when we burn these fuels, they tend to have remaining traces of sulfur in them, especially coal. And both coal and oil burn at such high temperatures that they can cause nitrogen and oxygen in the air to form different compounds. So imagine we have here an oil refinery and a coal burning plant and a lot of cars. A common byproduct of coal burning plants or smelters and other industrial facilities is sulfur dioxide, SO2. At the same time, high temperatures from combustion engines and oil refineries provide enough energy to break apart nitrogen and oxygen molecules in the air. These molecules can then recombine to form different nitrogen oxides, like nitric oxide, NO, and nitrogen dioxide, NO2. Together, these are referred to as nitrogen oxides, which you can abbreviate by NOx. So the same can be said about sulfur dioxide. That falls into the category of sulfur oxide, SOx or SOx. So a fun way to remember the precursors to acid rain are SOx and NOx. Now, these precursors belonging to the SOx and NOx family are hanging out up in the air. When they interact with UV radiation from the sun and water molecules that are also in the air, they form different vapors. These acid vapors, sulfuric acid vapor, H2SO4, and nitric acid vapor, HNO3. And these acids are no joke. Sulfuric acid is highly corrosive. It can burn your skin, the vapors can irritate your respiratory tract, and nitric acid is known to be used in explosives and rocket launches. And these are the acids that make up the phenomenon of acid rain. Over time, these smokestacks have actually gotten taller. One example in the early 1970s, when the EPA wanted to reduce emissions from these coal-burning facilities and oil refineries, to control the air quality around those communities, what these facilities did was build larger smokestacks or taller smokestacks so that those pollutants would disperse and spread out over a larger area and not fall over the local community as much or as fast. Instead, what ended up happening is that these pollutants were carried by the wind to communities and natural environments downwind of where they were being created, up to 1,000 kilometers or over 600 miles. And when these acid vapors cause acid rain, it's not always rain like we think of with water falling from the sky. Acid rain is just a general term, and it really includes all forms of precipitation, like snow, fog, cloud vapor, and dry deposition like dust particles. And also, it can have different combinations of these forms. And now the other big question is, why does it matter, right? How are we affected? And also, does that acid burn your skin? A very logical thing to want to know. So for cities, first of all, acid rain is bad news because it can damage buildings and statues, particularly those that are made of limestone, marble, and some metals. Here in this photo is a gargoyle from the Munich town hall, which is almost unrecognizable because of all of the damage it sustained from acid rain. There's also been a lot of studies over the years looking at the US Capitol and a lot of the surfaces there that are made of marble and how they can strengthen them to protect them from acid rain before it's too late. Now, if we go a little deeper, acid rain can leach or pull out heavy metals like aluminum from the soil or rocks, which can then be washed out to lakes and, as you can imagine, can lead to a lot of bad things like contaminating drinking water and harming aquatic ecosystems. Many fish can't survive at a lower pH. Acid rain also has impacts on other natural environments, especially because of how far its reaches. Acid rain can damage and weaken forests and trees by stripping nutrients from the soil and even damaging the waxy outer coat, leaving them much more vulnerable to losing more nutrients. Now, when it comes to humans, these acid vapors and the different precipitation that they create are very harmful to our respiratory system, and especially those that have asthma. And of course, I have to answer the question, does acid rain burn your skin? The answer is no, it's just not acidic enough. Remember, acid rain is around a pH of 4, and for something to burn your skin, it has to be much more acidic, usually around a pH of 1. There is some good news when it comes to acid rain. In 1990, the EPA created the Acid Rain Program to help power plants reduce emissions. In 2019, when they looked at the levels compared to 1990, they saw pretty great reductions. A 94% reduction in sulfur dioxide and an 86% reduction in nitric oxides. Now, this is in the United States, but around the world, acid rain is still a problem, particularly